All right, so again, I don't know why my little n is up there floating in the air. Just ignore that. Okay, so we want to graph the tangent of x. Y equals the tangent of x. I'm going to use the same divisions that I was using for my sine and cosine graphs. I'm going to use the quadrantal angles. So start at 0, then pi over 2, pi, 3 pi over 2, 2 pi. And I also am going to go backwards on this one. We go negative pi over 2, negative pi, just to kind of put a few more things on this one. All right. So remember, there's places where the tangent's undefined, right? Tangent is sine divided by cosine. So wherever the cosine is 0, we got problems, right? So think about your unit circle. Where is the cosine 0? Where's the tangent going to be undefined? Okay. I hope you're thinking pi over 2 and 3 pi over 2. Okay. The period for the tangent function is pi. So in between any of these vertical asymptotes, we have a space of pi, a period of pi. So let's see. Think of your unit circle. At 0 radians, what's the tangent value? Should be thinking 0. Same thing at pi. What's the tangent value? Back around at 2 pi. Okay. So the graph of the tangent function is very much like so. And it just keeps repeating. And I just drew several repetitions of it so that we would have it on our graph. Okay, so we can do everything that we were doing with the cosine and sine functions. We can do it with the tangent function. So for instance here. All right, let's see. So start here. What does this do? Do you remember? That's omega. So that's the thing that affects the compression and the stretching on the horizontal axis. That's the thing that affects the period. All right, so remember how we did that? We said, well, the period for the tangent function is usually pi, and we divide it by omega, and that's 4 pi for our new period. Okay. Now, be careful with the trig functions, right? If it starts with the tangent function, if it starts at 0, 4 pi, the asymptotes were here and here. And what this is saying is I'm supposed to be able to get a whole period in between 0 and 4 pi, and I can't. Usually we don't draw the tangent like this, though, because that just looks so weird. We almost always continue. But I did want you to keep in mind, you're going, one period is from 0 to 4 pi, and you do actually get the whole graph. It just doesn't look as cute as it is when it's connected. Okay, now you do need to put your values on the rest of the tick marks there, because we need to know where our vertical asymptotes are. So if that's 4 pi, half of that's 2 pi, this one would be 6 pi. So we've got that. And I'm not going to go any further to the left. Okay. What does this get us? It's a shift up, right? So I need to put a scale on my y-axis. Basically, all it's going to do, just going to pick this thing up. Like so. Oh, that looks rough. Sorry. Okay. How about cosecant? Oh, you know, one thing though, I did want to point out. Notice that the scale, this one would be much more stretched out than this one. Because notice here, like I drew everything on the right between 0 and 2 pi. I had 2 repetitions of that graph. Whereas over here, I only get 1 repetition by 4 pi. I only get half of a repetition by 2 pi. So this is a much more stretched out graph than the first one. If I were to put them on the same axes, you would be able to see it. So again, I think I said it with the other video. I want to make sure I say it here. When I'm graphing by hand, I'm paying attention to my units on my axes. I'm trying to get the basic shape of the graph. The scale part, unless I'm going to put 2 of them on the same set of axes, most of my graphs do tend to look alike, and I have to look at the scale to think, oh, okay, which one's fatter, which one's skinnier. So do be aware of that. Be careful. You'll notice that when you look at the graphs, once you do it by hand, when you look at a graph, say on the computer, you will see that it actually is they almost always use the same scale, so they will look all squished up or spread out. Okay, now cosecant. All right, cosecant is the reciprocal of the sine, right? So first thing you do is you graph your sine function. All right, remember how that goes? Let's see. Let's put our angles on here. Pi over 2, pi, 3 pi over 2, 2 pi. And again, I'm just going to go back a little bit on this because I'm trying to show the cosecant graph. And it repeats differently than the sine and the cosine where it's not connected, where it has the asymptotes. All right, let's see. 1 and -1. All right, so sine starts at 0, 0. Starts at 0, 0. Goes there, goes there, goes there, goes there. All right, let's see here. Like that. Well, it's not pointed, it just kind of did that. Okay, so now that's my sine graph. Remember the cosecant's the reciprocal of the sine. So everywhere the sine equals 0, the cosecant's going to be undefined. So it's going to be undefined here, and here, and here. And I'm just drawing a bunch of them again for your notes. And I'm going to change colors. All right, so then the cosecant graph, sits up here, runs beside the asymptotes, comes down here, runs beside the asymptotes, and there. Okay? All right, let's try this one. All right, so we're going to draw the sine function. What are we going to do with it? We're going to flip the sine function. It's going to have an amplitude of 2. What about its period? Remember, to find the period, it's 2 pi over omega. Omega is pi. So 2 pi over pi is 2. All right. So I'm going to draw the sine function. It's going to have an amplitude of 2. My divisions, let's see, the period is 2, so it starts at 0, it goes out to 2. So half of 2 is 1, half of 1 is 1/2, and then to get the missing one, 1/2 plus 1 is 3/2. And starts at 0, 0. This time we're going down because it's flipped. And let's see, so it's going to go like and here, here, here. Like that. All right, so does that get everything? I flipped it. I stretched it to 2 and -2 for the maxes and the mins. I changed my period. The period was 2 pi. Divided that by pi, that becomes 2. All right, so now I'm ready for my actual cosecant graph. My asymptotes go where the sine function equals 0. So my little function goes here and here, here, like so. Okay.